In this course, we'll be covering data structures and algorithms in C#. The course will primarily cover collections and generics, arrays and array lists, basic sorting algorithms, searching algorithms, stacks and queues, the bit array class, string class, pattern matching and text processing, dictionaries, hashing, linked lists, binary trees, sets, and sorting algorithms. We'll also cover data structures and algorithms for searching, graphs and graph algorithms, and some advanced algorithms. First of all, we'll be starting with collections in C#. So if defined, a collection is a structured data type that stores data and provides operations for adding data to the collection, removing data from the collection, updating data in the collection, as well as operations for setting and returning the values of different attributes of the collection. Collections can be broken down into two types, linear and non-linear. Linear collection is a list of elements where one element follows the previous element. A very basic example of this kind of collection is an array. Non-linear collections hold elements that do not have positional order within the collection. So first of all, we'll be exploring linear collections. Now there are two types of linear collections, direct access collections and sequential access collections. Under direct access collections, we have arrays, string, and struct. Now a struct is a composite data type that holds data that may consist of many different data types. So let's go ahead and explore these in action: arrays, string, and struct. So here, first of all, we'll be taking a look at the string collection. This is a type of direct access collection, and when we define a string, it is basically a collection of characters that can be accessed based on their index. In the same manner, we access the elements of an array as well. So here we have created a string array, and this string array is containing two users, that is John and Matt, and you can see that we can access the values using their index positions, and they are all in sequence. So at 0 we have John, at 1 we have Matt, and if we have more over here, we can just go on with that sequencing like 0, 1, 2, and 3. And here we are just writing those values, users of 0, users of 1. Now the other type that we discussed was struct. Now here, if you take a look at this example first, the integer data type that we have in C# is basically a struct. So if I go ahead and say here int 32.parse, and if I take you to this definition, you can see that it is a struct data type. And this also comes under direct access collections. The only difference between a struct and a class in general is that you cannot inherit or derive a new type from a structure. So here you can see that we have created a struct called name, and this has got three attributes: first name, middle name, and last name. This is the constructor that we have, and it basically initializes all these attributes that we have: f name, m name, l name. And then we have these properties which returns first name, last name, and middle name. And then we have overridden the toString method to just return first name, middle name, last name as a full name, and here we are returning initials. So first letter of each word will be shown over here. Now in order to use this struct, you can see that we have created it over here, initialized it, and then we have passed these first name, middle name, and last name, and these two variables that we have will store full name and initials. So full name is coming from myname.toString, and initials coming from myname.initials. Now if I go ahead and run this, you'll notice the output is coming as John and Matt from the array example, and then this is the full name, initial, and here we were converting integer from string. So here if I enter a string, it will be converted and printed as an integer value. Now in the next one, we'll be covering sequential access collections.